Delta IV Heave Y launches NROL-70.
The Delta program, spanning 60 years, came to a close with the launch of the final Delta IV Heavy rocket by United Launch Alliance, JULA, at 12:53 p.m.
FTS.
EDT from Space Launch Complex 37 at Cape Canaveral Space Force Station, Florida.
The rocket, carrying the NROL-70 mission for the National Reconnaissance Office, marks the end of the Delta era and initiates the future of heavy lift on ULA's next-generation Vulcan rocket.
Mission Overview.
A United Launch Alliance ULA Delta IV Heavy rocket is launching the NROL-70 mission for the National Reconnaissance Office, NRO. Liftoff will occur from Space Launch Complex 37 at Cape Canaveral Space Force Station, Florida. This is the 16th and final launch of a Delta IV Heavy rocket. The NRO develops and operates the world's most capable and innovative overhead reconnaissance systems to collect intelligence for U.S. national security and to support disaster relief and humanitarian efforts. The NROL-70 mission will strengthen the NRO's ability to provide a wide range of timely intelligence information to national decision-makers, warfighters, to protect the nation's vital interests and support humanitarian efforts worldwide.
Launch Vehicle. Payload Fairing.
The payload fairing, PLF, is a metallic trisector, 3-piece shell, 5-meter diameter fairing.
8.
The
7,
PLF
6,
encapsulates the
5.
spacecraft to protect it from the launch
2,
environment on ascent.
1.
The vehicle's height, with the 65-foot
And liftoff of the
19.8
final
meters
United
long
Launch
PLF
Alliance
is
Delta IV
approximately
Heavy rocket
235 feet,
carrying NROL-70 for
71.6
the
meters.
National Reconnaissance Office and closing Delta's 6-decade legacy of excellence in space.
Is that mid-power level? Port and starboard strap-on, still operating at enhanced power level.
You are hearing the voice of Rob Gannon providing launch vehicle ascent data.
Parameters look good. Flight control purposes look good. And we have fired the isolation spiral valve on second-stage reactor control system. And first step is ready in that system for operation. Continue to look good. And we passed through Mach 1 and Mach 2. Normal surface there, everything looks good. All three systems operating as expected. Operating as expected. Everything looks good. Fired the power valve, pressurizing the reactor control system. Second stage, system pressure stepping up. Everything looks good. What we're looking for is going to
Delta Cryogenic Second Stage, DCSS.
3 or 4 seconds.
The Delta Cryogenic Second Stage is a cryogenic liquid hydrogen-liquid oxygen-fueled vehicle, powered by a single RL-10C2-1 engine that produces 24,750 pounds, 110.1 kilonewtons of thrust.
And we are 3 minutes to
propellant tanks
Corbico.
are structurally rigid and constructed of formed aluminum plate, spun formed aluminum domes and aluminum ring forgings. The tanks are insulated with a spray-on insulation and helium-purged insulation blankets. An equipment shelf attached to the aft dome of the DCSS liquid oxygen tank provides the structural mountings for vehicle electronics.
Now 29
Booster.
nautical miles in altitude.
The 3 Delta IV Heavy Common Booster Core CBC tanks are structurally rigid and constructed of isogrid aluminum barrels, spun-formed aluminum domes, and machined aluminum tank skirts. Delta IV booster propulsion is provided by the throttleable RS-68A engine system, which burns cryogenic liquid hydrogen and liquid oxygen, with each of the 3 booster engines delivering 750 pounds, 312.3 kilonewtons of thrust at sea level. The booster's cryogenic tanks are insulated with a combination of spray-on and bond-on insulation and helium-purged insulation blankets. The booster is controlled by the DCSS avionics system, which provides guidance flight control.
Now achievement power level on the strap-ons. And cut off. We have cut off port and starboard boosters coming up on strap-on set, and we have strap-on separation. Disturbances look good. Throttled up the core booster. We're now at EPL on the single stage booster. And we've enabled steering following separation of the strap-ons. Everything looking good.
We just heard confirmation of port and starboard booster jettison. We have about a minute and a half until we reach our next mission event, booster engine cutoff.
The RL-10. One minute to core BECO. Yeah, housing temps respond as expected on the RL-10, and we've started LH2 boost phase chill down. Housing temps responding as expected. Flight control disturbances are small, and core RS-68 continues to operate as expected. About 20 seconds to our next mark event, throttling down the core booster in preparation for BECO. And core booster is throttling down, coming up on booster engine cutoff. And we have BECO. Cut off on the booster, everything looking good. And state preparation occurred right as expected. NEDs have deployed. And we have pre-start, start, and full thrust. RL-10 is up and running normally. Everything looking good. Enabled steering of the second stage. Second stage operating normally. Coming up on bearing separation. About 10 seconds away from bearing sep. Five seconds to bearing sep, and we have bearing separation. Disturbances look good. Upper stage is operating normally. And once again, steering has been re-enabled after the separation event.